workshop lecture 4. Today we're going to be talking about problem-solving pedagogies. As you know, there are many different kinds of pedagogies that take place within education, and they tend to change depending on the type of education context. So there'd be different pedagogies, for example, that we use at university. There are different pedagogies that tend to be used at high school, and then at primary school, and then the prior to school settings. And so when we talk about pedagogies today, it's with those prior to school settings that we're going to be thinking about. So birth to 5 pedagogies. It might seem that there aren't many different ways to think about pedagogy in that space, and certainly we are foregrounding in this course a play-based approach to pedagogy. And so that underpins everything that we do, but within that there are kind of nuanced ways in which we can tune what we want to work with children on, and how we want to do that, and how we help children kind of do different kinds of learning activities for different purposes. And so today I'm going to kind of just do an overview, and I suggest after you've watched this lecture that you have a look at the resources we have in the Canvas page for this particular workshop, but also have a search on the web for resources relating to some of the things that we talk about today to get some kind of more information. So what we're going to do is we're going to look at, I'm going to relate the different types of problem-solving pedagogies to the kind of aspects of STEAM. I'm not going to go through each of the letters, but I'm going to kind of cluster the pedagogies into certain types of activities. And on each slide that I pop up relating to these different pedagogies, you'll see some distinctions and also some similarities. And of course there are many different kinds of additions to the list that I've got. So you'll start to kind of see more similarities perhaps as we go through. But just bear in mind that everything we talk about today is with the notion of children learning through play, and also this is for very young children's learning. So if we think about problem solving as a concept, and why we have problem solving in our education systems. Now, I am pretty old now, but I did go through a school system that was very much based on experiential learning, and that's because I was at school, I started school in the 1970s, and at the time this was the kind of pedagogical theory that was starting to take place. It has since changed from that, and so my education experience is very different, for example, to the education experience of children going through school today. And that's because the theories about learning change. But before my schooling experiences, for example, my grandparents' schooling experiences were not based on problem solving. It was based on what's called rote learning, or what we kind of call chalk and talk. So this is where the teacher held all the knowledge. It was a kind of more of an apprentice-based approach, which was the children come to the classroom. There's an assumption that they have very little information of their own or very little capacity of their own, and they need to learn everything by watching and learning and being instructed by the teacher and being explicitly taught by the teacher. And it's a one-way exchange. And so we understand now, as we do more and more research into education, that it's actually really vital to have the child actively participating in their education. And one of the ways that we do that is through play, and one of the other ways that we do that is through having problem-solving activities and learning at the core of the curriculum. And so this slide is about why problem solving, as we've begun to see and understand why it's so important. And these are just some of the terms that you'll read if you are looking at problem solving pedagogies, or the kind of crucial benefits of problem solving in the curriculum and in children's learning. So we'll just talk briefly about each of them here. So the first one is high order thinking, and this relates to theories of learning that kind of surfaced probably about 15, 20 years ago now, which was about how we understand that when we give rich experiences, rich tasks for children to do, it forces them to use lots of aspects of their brain that are more beneficial for their intellectual growth, if you like. So if you think back again to that experience of learning that my grandparents would have had, where they're just passively receiving information, because the habit of that is so similar each time, parts of the brain are not being engaged. Like, only certain parts of the brain are always being engaged. And so many years ago, there were, Bloom's taxonomy, for example, was an education theorist who looked at what the different types of activities that children engage with in school, how they prompt certain types of intellectual capacity, and that rote learning is actually one of the lowest forms of intellectual capacity. So, because it's just memorization, and so problem solving engages us in these kind of more difficult, uncertain, undefined things where we have to do a lot of independent work. And the more that we do that, the more that we engage in larger parts of the brain, and therefore it ignites this notion of high order thinking, because we're working harder actually to do the task. So that is one important aspect of problem solving in learning. And so when we give children, for example, very young children, puzzles, there's lots of puzzles in a kindergarten, and children have to solve the puzzle. They have to put shapes through shaped blocks through a hole, for example, in the baby's room, or young children have to learn how to layer colours on top of each other to make new colours, or they're learning how to write letters, or they're learning how to cut around a shape, for example. Some of those skills are quite hard. They're very foundational, but they're very tricky for very young children to learn. And so they are engaging. The more that we give independent learning out, the more we're giving young children the opportunity to have to use their own independent capacities. When we structure it a little bit more in terms of the activity, so they're not just things laid out on the table for a child to pick up and do, but we actually start to curate that a bit more, the activity a bit more as a teacher, what we're engaging then is teamwork. So, for example, if we want children to build a den together, or we want them to find things around the kindergarten outdoor space, and they have to bring them back, or maybe they're working on a puzzle together. They're kind of helping each other look after the chicks that are in the kindergarten room, all those kinds of things. They're engaging in teamwork. And problem solving, as soon as you involve more than an individual, then there's problem solving pops up, because you've got two human beings trying to interact with each other. And so the teamwork itself ignites problem solving skills. And so, again, important to set individual tasks, but also collaborative tasks, which is why when you're at university, you have both of those kinds of tasks as well. So you'll have individual tasks and group tasks. So for your assignment with the Wicked problem solving, this is exactly what you're engaging in too. So, as adults, you are actually participating in all of these capacities. You're engaging all of these capacities. And there's a little bit of bravery here. So you have to kind of be brave in addressing things, in addressing perhaps conversations, addressing experimentation. Maybe your ideas might not work, but you kind of have to try them. So this notion of bravery is also a really good learning skill. It teaches us to kind of go out on a limb, if you like, and to experiment with things. So the notion of bravery is really crucial, and of course for very young children it's especially crucial, so that they start to be an active participant in the world and they gain self-confidence. Experimentation is really, really important. So you know, sometimes I go into a kindergarten space and I see equipment in there that doesn't require a lot in terms of what the child contributes to it. So for example, it is almost pretty much heavily designed. There's not much that is needed to be done beyond the child kind of pressing a button or watching something. And so that they're less kind of effective as toys or equipment, because there's less experimentation opportunity within them. And so if you give children, for example, string, boxes, tape, scissors, the possibilities for experimentation with those is endless. Whereas a heavily designed toy that requires a button to be pressed so that the lights go on and the sound comes and the toy moves, there's very little, there's a lot of experimentation gone into the toy, but not a lot for the child to do. So actually, you know, the importance of problem solving and the better things you'll see in a kindergarten are the ones where there's lots of kind of very non-altered or very kind of raw material type stuff. So they are great kindergartens, and you'll see those rooms and where the children really have to work hard to make something with these basic materials. And again, problem solving through experimentation. Those raw materials also give many possibilities. So the many possibilities links to experimentation, and it links to bravery. So it's about if there's only one possible way of using something, there's not room for actually thinking, well, I wonder if I did this, or I wonder what would happen if I did this. And so that's kind of that notion of examining what is possible, what the potential of this material or this activity could bring. So experimentation is to do with the materiality of the equipment, and the possibilities are the kind of intellectual or the meta aspects of the materials. So what could a box become if you think of it like that? So it could become a house, it could become a tunnel, it could become the inside of your eyeball, whatever. So it's about the kind of corporeal possibilities that relate to the material, the experimentation with the materials. Of course, when you're doing all of this work, and again, this is why we, as educators, we always set team or pair work or non-individual work, is that it engages you with social and interpersonal skills. And so you have to negotiate, you have to discuss. You might be disappointed because your idea is not taken up. It might be that you have to find a way of working with somebody that you don't connect with, but you are given this task to work together. We know that in kindergarten spaces, it's a very, very much a shared social space. And so, you know, you've got, and children can move freely around the space. And so young children learn very, very quickly how to adopt social strategies or interpersonal skills, because suddenly where they are in the kindergarten is populated by other people, and they can't control who comes and goes. It's not down to anyone where the children are, so children can decide where to go. And so again, within the birth to 5 context, these are really vital skills to really help children develop before they go into the more formal setting of school, where they are in a classroom all the time, they're with children all the time. There's no opportunity for them to get up and wander off into a more quiet space. And so problem solving, it kind of it is an activity that really helps to develop social and interpersonal skills. And of course, then with those skills comes the intrapersonal, which is how you learn to negotiate yourself and how you think about yourself as a person, and how, and even young children learn to kind of reflect on perhaps why they feel sad about things or angry about things. As adults, we can be a bit more kind of attuned to how we shape those ideas. So it might be that maybe one person in your wicked problem solving group won't listen to you very well, or maybe they just won't, maybe they have a way of doing something that you're not used to or you don't feel comfortable about. So the external aspect of dealing with that is obviously the interpersonal, but thinking about who you are as an individual and why is it I get so bothered by this, or what can I do in myself, because I have to take responsibility for this as well. It's not me just being annoyed with this other person. I'm not neutral. I am a person as well, and I have a personality, and what are the things that I'm doing and what things can I change about myself. Children learn that you're going to learn those skills. Children learn those skills as well. So setting up problem solving activities actually brings about all these really vital and rich skills. So what we'll do now is we'll go through, I have 4 slides, and we'll go through problem solving with different kinds of pedagogies. So how we perhaps start to think about problem solving in curated ways, okay? So this is problem solving creatively. What kinds of ways? So we're not thinking here about, I'm not giving you tips on what types of activities to do, but actually to think about your pedagogic behaviours and your pedagogic ways of bringing about teaching in the classroom. So what does problem solving creatively actually do through, and what kinds of pedagogies develop certain types of skills or happenings in the classroom? So creative pedagogies will encourage children to think of alternative worlds. So the types of activities that you would set young children is to get them to think of these alternative worlds. And what you're doing, so each of these pages, I'm giving you kind of pedagogic tips, but the learning that takes place is also creative. So it's a kind of, it's a paired thing that's going on. By teaching creatively, you're enhancing the children's creative potential and their creativity generally. So a task might be to develop learning and teaching materials, develop content materials that get children to think of alternate worlds. And they can be worlds that are in the future or in the past, or completely imaginary, like a world that is in a story, or a world that's on a different planet, for example. Scale is also good. So you could be in the present, but thinking of the world of ants or elephants or a bird. So the things that live amongst us that we don't share the lives of. So again, alternative worlds from different positions. Not being contained by rules. So one of the great benefits of creativity is it is expansive. It disrupts rules and regularity. So you will often spot creative children in your class because they will often do something that you haven't asked them to do. They will just do what they want to do. And this is often why creative or artistic children particularly are often turned off by school because they can be misbadged as being naughty or subversive. But actually, what they're doing is they are not being contained by the rules, and that's actually fine. That's actually fine. You will spot these children, and they are children that they have enough independent capacity that they don't need to be restricted by rules. They want to actually burst out of them. And that can be frustrating as a teacher. It can be really frustrating because you want people to do what you've asked them. But then you have to think of that in terms of your own motivations and what's actually going on here. You have to think carefully about what's going on here for the child. And what's actually being done here is not naughtiness, but children actually thinking outside the box, which we desperately aspire adults to do in the job market. And it's interesting that we want that in people, but we squash it in schools. So don't be that teacher. Look out for those children who don't do what you ask in terms of the work that they produce. If children are producing work but in their own way, that's not them being naughty, that's them being creative. So the great thing about problem solving creatively is to engage in activities that are whole body learning. And so we know that in the arts, for example, we have music, dance, drama, media, and visual arts, and they're all quite active. They engage the whole body and they're quite active in their nature. And so again, think about, what am I always getting children to do? And are they always sitting, or are they always standing in a certain way, or am I getting them to move? So children might be standing up but actually not moving. Am I making them do big shapes with their bodies, small shapes? How am I thinking about the whole body in the activities that I'm setting them? Multiliteracies, of course. So creativity is about the languages that we use across different media and different arts practices. And so when you're dealing with birth to 5, this is core, because children, of course, at this age are learning speech, they're learning words and vocab. Most of them can't write, most of them can't read. You'll get 1 or 2 children who can start to do that as they head towards 5. But it's not uncommon for children not to be able to do those things. And so you've got to use other kinds of literacies. I always say in my teaching that if you don't engage in the creative arts as a birth to 5 educator, that is like you going to teach in a classroom in Australia where all the children speak English and you speak Russian, because it's actually a language. It's all those languages. So if you don't practice and learn about the languages within the arts, you're actually not communicating in the language that the children are using. And so it's a very impoverished relationship. So really vital that if you are at this point not confident in the arts, or you don't really know much, you've actually committed to being an early childhood educator. It's the very least you can do is to go and actually learn the language that these children are speaking. Okay, so, and therefore set activities and set tasks, because children rely on those other languages because they can't read, they can't write, and they're learning how to speak. Speculative. That means that problem solving creatively is as an educator, you don't tell necessarily the children what you want to have at the end, that you just offer a problem or a provocation, or you offer the materials and you say, let's see, what can we do? So the idea of being speculative is actually, what's possible here? Where might this go? What can we discover as we go along? What might emerge as we go along? And so lots of education activities for problem solving by not setting a defined endpoint. Of course, that then brings in imagination and really encouraging children's ideas, being very enthusiastic, thinking about why some children, imagine all kinds of potential possibilities. Children imagine about, and particularly when we think of alternative worlds, it's a really good opportunity for children to use their imaginations. What would be the language that these creatures from this other planet speak? What food would they eat? What do they look like? All those kinds of things. So you're asking children really to tap into imaginations. Similarly, what is it like, do you think? We've found some ants in our kindergarten garden. What does the world look like from the perspective of the ant? What can we imagine? So lots of opportunities for problem solving through those creative engagements. Multiple ideas. One of the things that really typifies creative people is they are not afraid to have bad ideas. They will often go, oh, what about this? Oh, we could do that. What about this? What about that? And some of the ideas won't be very good. But what's typical often with creative people is they don't care if an idea is bad. They just keep going. They just keep trying. And it's important not to shame those ideas and say, well, that will never work. Oh my gosh, that's a silly idea. And similarly in your groups, as you're going through your problem solving groups, those of you who are creative, you will have lots of ideas, and it's really important that you get to share those ideas. It is very typical of creative people to actually brainstorm heaps and heaps and heaps and heaps of ideas, and through that process, some strong possibilities emerge. So encourage it at all costs. And sometimes it's illogical. Like, what if we did balance this great big heavy brick on this matchstick? So again, it's about the idea of the alternative thinking outside the box. And sometimes it's highly illogical, but the highly illogical can work, can generate really incredible ideas and things to happen. So yes, don't be restricted by what you expect at that point. If we go to problem solving scientifically, so the kind of pedagogies that we engage with in terms of science, science learning, and then science advances. Science is a really interesting discipline and area of learning, because it kind of bridges the very kind of procedural but also the highly experimental. So it's really important to have lots of scientific pedagogy and scientific learning in your teaching. And it's important for those of you in your problem solving groups who have a strong kind of scientific capacity to use them, because it's got vital skills within it for problem solving. So some of the ways in which scientific pedagogies work is to introduce children to procedure, for example. So when you're doing an experiment, a science experiment, many actually science experiments rely on protocols being followed really carefully. And so you can introduce children to that with simple science. So for example, a simple science procedure is to keep our tummies healthy by washing our hands and drying them properly before we eat, for example. And so that's a scientific procedure. So hand washing or cleaning our utensils in the same way. So you can introduce children, very young children, to the scientific procedure of hygiene by saying we wash our hands before we eat. Sometimes we wash them after as well, but we always wash our hands before we eat, and we always wash them this way. And this is really vital at this point where we're living through a pandemic, how we're helping children understand how to wash their hands properly. So that's a scientific procedure you can introduce to children. We repeat it. So if we think about the science community and the kind of high-level science that takes place, we need to understand how things can be repeated so that it works each time. And so something about repeating a repetitious activity is actually really important for children to understand about the value of that in science learning. And so I'm sure you can think of some Repeated actions, for example, could be around plant science. So if we don't water the plants every day, or we don't, repot them, or we don't put a little stick to help them grow, those then they don't thrive. But certainly the repetition of watering plants, really important, or feeding the pets, or those kinds of things. So the repeated action allows children to understand about the science of growth and nutrition and all that kind of stuff. When we're doing science experiments, it can be propositional. So, what happens when we put the ice cube tray in the freezer? So, when we're thinking about matter, for example, often in kindergarten spaces, we start with water, because water is really phenomenal. It can be 3 types of matter. It can be a liquid, a solid, and a gas. So it's really fascinating for young children to learn about matter through water. And so we can set up this notion of the proposition. If we do this, then what happens? And if we have a proposition, my guess is that if we do this, then this will happen, and we follow a procedure. So the idea of something, this is quite different if you think about what we're just discussing with creativity learning, but to problem solve scientifically has slightly different nuances, and we start to think slightly differently. It can be very sharply focused. That is not big picture, but quite specific, very specific. We need to solve this specific problem, and we're going to attack it this way. And if we think about medical science, for example, this is how we start to understand how to combat diseases or illnesses, by being quite specifically targeted at certain aspects of that disease. And so you can introduce a sharp focus. You can also think about that in your pedagogy, how it's sharply focused on a very specific aspect of the world, for example. Testing, very, very interesting. So we set up different procedures, which one works. So we test. That's really good. So, you can have like 4 beans in a pot, in 4 pots. You water one every day, you water one none, you put one in a dark cupboard, you put one in the sun, etc., etc. And so you can see what the testing does for the conditions. However, science is also experimental, and it can be highly speculative and very creative. So we know that, for example, scientists wondered whether they could make it where we could put people on the moon. Highly experimental and speculative. So, what's possible with science? We know that what's possible if we understand now about gene replication, plant splicing, genetically modified plants. This is irrespective of whether you agree with these things or not. These things are in the world and they're taking place. And so that's a kind of example of experimental and speculative science. So it has these 2 sides, if you like, and you can explore them in your wicked problem, and you can also explore them in your teaching. So we also have problem solving technically, well, this is very materialistics based. It's often mathematical. So if we do this with the materials and we put this much pressure, and we kind of equate this with this action, and we do this, so it's a kind of mathematical approach to problem solving. So if we think back to those scientists that wanted to put astronauts on the moon, the technicians came in and they tested the materials, and they tried the mathematics of thicknesses against force and all that kind of stuff. So the technicians and the technical minded are really vital in problem solving, and it is very a materials based way of working. So you'll find that children with good math skills, yourselves with good math skills, and those of you that like playing with materials are going to really approach problem solving technically. It's constructive, how to build something, how to build a solution to this particular problem. And it is procedural as well in terms of following, kind of building rules, or to at least construction kind of ideas. And it can be experimental in that as well. So, how might we think about the technical capacity of bamboo to to build a bridge, for example? So technician would work quite closely with an engineer, for example. There's the design of one thing, and then the technician is how this materiality will work in terms of seeing the engineer's vision come to fruition. And so when you are doing group work, you can start to see how these different capacities complement each other. So you've got the kind of unfettered thinking and ideas generation in the creative person. The technical person's thinking about materials for this, and how something might be, possible materialistically. And then you've got the scientifically minded, or the aspects of us that are interested in science. Of course, we go across these. Many of us have all of these capacities, and we're picking them up through these problem-solving challenges. So this is why you're having this wicked problem. So some of you will gravitate specifically towards the technical, or the scientific, or the creative, and some of you will have more than one of those skills, because we're humans and we have this incredible capacity. So, and then the final one is the logistics, which is a kind of engineering capacity. And again, this has a materialistic bent, and it is, but it's the kind of design side, if you like. So, the engineer thinks about, what are the different ways I could build a bridge? What are the different ways I could start to make sure this road doesn't crack and do all this kind of stuff? So what are the different ways I could design a watch that would, work underwater, and so forth? So you've kind of got the engineer who's thinking in terms of design, and then the technician works with the engineer to focus very much on the materiality of those designs. So it is materialistic. It's thinking about what's possible in terms of putting materials together, how we build things, how we want to make things that from materials, like from the combination of materials. So, an engineer skill with an artistic skill is really quite amazing, and you get you start to kind of imagine all these incredible kind of possibilities. I don't know if any of you have heard of the Burning Man Festival, which is like a big rave festival. It's been going for many years. It goes on in the desert. If you're interested, have a look at some images from the Burning Man Festival, because it is what's a big feature of the Burning Man Festival are these enormous kind of constructions that they're like sculptures, but the materials that they're made with, and they set them on fire, and it's part of the festival, and it's hence why they set it in the middle of a desert, because they can't set fire to anything around them. But the complexity and the sophistication of these constructions is mind-blowing, really. They're enormous, they're quite beautiful, and the artists and the engineers and the technicians work together to understand how to build them. And then you've got the science around what happens as they set fire, because they want them to look a certain way as they set fire as well. So the Burning Man Festival is a really good example of how that all of those types of ways of thinking work together in something that is quite phenomenal. So I don't suggest you do anything like that in your classrooms, but you could think of things whereby you've got these different types of capacities, these problem-solving capacities, to work in combination. So where you've got the engineer and the logistical kind of tendencies to come in, is where, again, engineers are experimental, they're highly experimental, but they also have a logical side. So they, the thinking is about what's possible here, what can this material do, how far can I push it, and it's causal. So there's, if I do this, will this happen? If I do this, this is likely to happen. So I need to go back and look at the materials and keep experimenting so that when I do this, what I want to have happen happens. So it's this idea of logic and cause. And the engineering kind of capacity is very systematic. So you kind of build up a sense of what materials can do, and those ideas connect together to build a bigger idea of possibilities. So, for example, you would know to use certain materials for certain types of tasks, and so these are the kind of ways in which you can think about problem solving pedagogically. What kind of tasks, what kind of activities would you introduce in young children's everyday learning that gets them to work together, and it gets these types of activities, these types of skills prompted by the activities that you set them. So problem solving is the way that that's done, and we do it through play, but we encourage these capacities logistically, these capacities through the technical, these capacities through scientific thinking, and these capacities through creative encouragement. Okay, so, and if we go back to the slide before, we think about those important aspects of growth and development for the children, but also as you go through your problem solving, you're actually engaging in these things as well. And so these slides will be available in the Canvas page, so you can download these and think about how many of these things you're addressing in your problem solving work. Not just your idea, but the ways in which you're working as a team towards the idea. Okay.